that aren't like quadratics or linear equations, and they have like weird things in them. The first thing that we looked at was the absolute value sign, which essentially just turns anything on the inside positive. Okay, so we learned how to do problems involving the absolute value sign. Now we're going to talk about a different type of equation that we haven't looked at before. And these are equations with square roots in them, or third roots, or fourth roots, and so on. Okay. All right, so just a little reminder, a square root or third root or fourth root is just a fractional exponent, right? For example, when we saw, I don't know, the fourth root of x, does anyone remember another way to write that? X to the 1/4, good. So a square root and a fractional exponent are basically the same thing. But we haven't talked about how to solve equations with these, okay? So let's just, actually, let me talk about one more thing with this example here. If we have x to the 1/4 or the fourth root of x, how do I, like, you know what, let's just go with the problem. I thought I was going to say something, but I decided against it. Okay, so here we have the third root of x squared minus 1 equals 2, and we want to solve for x. Okay, now I'm just going to rewrite the equation here so I can do stuff with it. Okay. So let's see, we have a third root or a fractional exponent. Does anyone know how to undo a third root? Okay, I like how you did multiply it by 1/3. That's close, but not exactly. Cubit, good. Okay, so multiplying is the opposite of division. So whenever we have a division, we multiply to get rid of stuff. When we have a square root or third root or something like that, the opposite is actually just another exponent, but not a fractional exponent. Okay, so to make that easier to see, I'm going to take each side and just raise it to the third power. So to undo a root, we take it to whatever power it's under. Okay, so on the inside, I guess the exponents cancel out and we're left with x squared minus 1 on the left. And 2 cubed is 8, right? Perfect. Do that in my head today. Okay. Now we can just solve for x, right? And this is pretty easy. I think we just add 1 to both sides, right? Okay, so if we add 1 on both sides, we get x squared equals 9. And then how do we undo a square? Square root, good. So kind of like the opposite of what we did at the beginning. X equals, and what did I just forget? Plus or minus sign, good. Plus or minus the square root of 9. You can leave the answer like this, but I think the square root of 9 is 3. So let's say plus or minus 3. Okay. So pretty simple in how to solve these guys. There is something that is that comes about with square roots and third roots and fourth roots. Oh, someone raised their hand. Oh wait, they unraised their hand. Okay. All right. So the thing about square roots, third roots, fourth roots, things like that, is when we have these, you have to plug the answers back in to see if they work. Okay. And sometimes everything works out, which we'll see that this example does. But then we'll talk about ways in which this might not actually work for us. Okay, so why don't we just check our answers, plug back into the equation like we kind of normally do. I'm going to check -3 and +3 separately. Okay, so let's check x equals -3 first. Okay, when we check our answers, we just plug it in and see if it works, right? So I'm really bad at making mistakes, so I'm going to recopy the equation under here just so I don't mess up. Okay. Plugging in -3, just plug it in, right? So we have the third root of -3 squared minus 1 equals 2. And I'm going to put a little question mark after it because we don't know if they're equal. We just kind of set it up. Okay. let's see, we have the third root. -3 squared is 9, minus 1 is 2. Okay, and then we have the third root of 8 equals 2 question mark. What's the third root of 8?
2.
2, good. If you're unsure, you can always type in your calculator. Okay. By the way, how would I type this into my calculator? How would I find the third root of 8 in my calculator?
Second on your calculator, and then there should be like a symbol that says like X squared plus Y. So you like type in
Mhm.
the number that you need, like would be 3 in this example first.
Good, good. So let me kind of go over what Riley said. So first you're going to type in the number, right? 8 that you want to take the third root of, okay? Then you're going to press, I think it's like X to the Y, that button brings something to a power. And what I would do is I want to take 8 to the third root or the 1/3 power, right? So why don't I take 8 and just raise it to the 1/3 power, okay? Now, my best advice for you is to put the fraction in parentheses because sometimes your calculator won't like it if it's not, okay? It might do something weird. So what I would do, press 8, do the power button. It could be a caret, it could look like X to the Y, and then type 1/3 in parentheses. That'll give you 2. Okay. Any questions on calculators, anything like that? Okay. So 2 equals 2, is X equals -3 a solution? Yes, good. All right, let's check X equals 3. Well, that's the same thing, right? I'm gonna rewrite my equation because I'm lazy and I'm bad at making mistakes. Okay, plug in 3 in for X, put a question mark. Third root of 9 minus 1 equals 2 question mark. The third root of 8 equals 2 question mark. 2 equals 2. Looks like we're good. Okay, so both of our solutions are actually solutions to our equation. Okay, let's take a look at when it might not be. Okay, so let's flip our page to the next one, and I want to talk about this one again. I will give you some time to work on these by yourselves as well today. Okay. So this time I don't have a third root, I have a square root, okay? And let's just take a look at what this is telling us to do. And while I'm doing this, I'm just gonna rewrite my equation here because I'm very bad at making mistakes. Okay, taking a look at this. Can I just kind of undo the square root right away? Or should I do something first? Not the X to the other side, but the 3 to the other side, right? Because if I have something weird in my equation, I want to get rid of it. The best advice is to get it by itself, right? You want to isolate it so we can undo it. Okay, so why don't we subtract 3 from both sides? So we have the square root of 3x plus 1 equals x minus 3. Okay. How do we undo a square root? Good. Just like undoing a third root was cubing it, undoing a square root means splitting it. All right, so take both sides and square it. Okay, so on the left, we're left with 3x plus 1. On the right, we're left with x minus 3 squared. Okay, here's where a lot of people mess up. What do I do next? Good. A lot of people I see on my test will take the 2 and move it to the x and the 3. Okay, don't do that. Okay, so if you wrote that down, please erase that. Okay, we're not distributing the 2. We're actually going to multiply x minus 3 to itself twice. Now, a lot of you can do this in your head. I don't. What I like to do is write the x minus 3 twice. Why? Because I mess up if I don't write it twice and draw the arrows. Now we can FOIL. Okay, so I'm going to take my arrows and FOIL out this right-hand side. I think we have an x squared minus 3x minus 3x plus 9. And the left-hand side is the same. Okay. So I FOILed everything out. Now everything's kind of expanded. Okay. We have like terms on the right side. Guess we can combine those. 3x plus 1 equals x squared minus 6x plus 9. Okay. All right. Any ideas on what to do next? Yeah, subtract the 1 on the left side. And while I'm at it, why don't I subtract the 3x from the left side too? Just so to get everything on one side of the equation. Minus 3x, minus 3x, minus 1, minus 1. So we're left with 0 equals x squared minus, oh gosh, 12x plus 8. All right. Oh my goodness, it's 9, isn't it? My arithmetic skills. When I was in elementary school, I hated math so much. I just hated it so much because everyone else could do these arithmetic stuff, and I was like counting with my fingers, and I still do. So, all right, but at least I can do algebra. Any ideas on what we can do there? Factor. Factor is a good idea. Looks like something we can factor. When we factor things, we need to find two numbers that add to which number? -9, good. And multiply to 8, good. Okay. What two numbers do this? -8, -1, good. Now, because this isn't a funky quadratic, which means in my head, there's something in front of the x squared. There's nothing in front of the x squared right now. Why don't we just stick our factors into the fully factored form? So this is x minus 8 times x minus 1. Okay, that was pretty easy to factor for me. Okay, now we have two options, right? We can set x minus 8 equal to 0. And we can set x minus 1 equal to 0. Okay, which gives me x equals 8 and x equals 1. That was a lot of work, right? Unfortunately for us, we're not done. We still have more work to do, and that's in checking if our solutions make sense. Okay, and this will show you exactly why checking our solutions might not work sometimes. We have two solutions, so we can plug them in, right? So I'm going to check x equals 8 first. Let's go with the hard one first. Okay. When we check our solutions, we go to the very beginning of the problem, okay, and we plug it in. So I'm going to write 3 plus the square root of 3x plus 1 equals x. That's my original equation. Okay. Plugging in 8, well, that's easy. 3 plus the square root of 3 times 8 plus 1 equals 8. Question mark. Just plugs in 8. Okay. Let's see if I can do this. This is like my worst nightmare here. 24 plus 1 equals 8 question mark. 24 plus 1 is 25. And the square root of 25 is 5. So we have 8 equals 8. Is 8 equal to 8? Yes. Yeah, good. So it looks like x equals 8 is a solution to my equation. So we're good so far. All right, let's check the other one. Let's check x equals 1. Okay. So I'm going to rewrite my equation because I make mistakes all the time. We have 3 plus the square root of 3 times 1 plus 1 equals 1, question mark. We have 3 plus the square root of 3 plus 1 equals 1, question mark. We have 3 plus the square root of 4 equals 1 question mark. 3 plus 2 equals 1. Oh, does 5 equal 1? No, right? So is x equals 1 a solution to my original equation? No, okay, so not a solution. Okay. Does anyone know what happened here? Okay, so we started with the square root equation, okay? And square roots have a different domain than other functions, right? Usually when we have a square root, we can't get negative solutions. To the iPhone answer, yes, there can be 2 solutions. Like the last equation we did have 2 solutions, but in example 6, we're just gonna have 1 because one of them didn't work out, okay? And the reason why is we started with a square root, okay? Then to solve it, we did something weird. We squared both sides of the equation, okay? When we squared, we essentially took away the square root, which took away something that was essential to our equation. We changed our equation in a way that kind of changed the domain of our equation. And I know that sounds kind of far-fetched, and we'll talk about domains later. But essentially, this equation here and this equation there are different equations. Okay, and we'll talk about how that kind of shows up later. But we essentially solved a different equation than what we started with. Okay. All right. Now let's talk about with example 6. This one had a square root. Example 5 had a cube root. Okay. Now I will tell you, if I ever give you a cube root or a 5th root or a 7th root or an 11th root, you're always going to have the solutions, all the solutions work out. Okay. The only time you have to actually check to see if your solutions work is if you have a square root, a 4th root, an 8th root, a 12th root. Anyone kind of realize the pattern here? Even roots, right? So with even roots, okay, you have to check if your solution makes sense. Okay. Now, the best practice for me is I always like to check my solutions make sense, but especially with the even roots, you do, because there is a chance that you essentially change your equation. You change the domain of your equation when you take the square of both sides. And sometimes your answers might not work out. So make sure you double check. Okay. Any questions on 6? All right. If you flip to the next page, we have another example. I want you to solve this equation. Remember to FOIL, and remember to check your solutions to see if they make sense. Around, I'm seeing pretty good answers, but let's just go over how we do these types of problems again. So I got Alex to write up solving the equation. Do you kind of just want to take us through your steps here? Mm-hmm. Yeah, looks really good. So we got 2 answers when we did all of this, which is normally what we're going to get when we square both sides of an equation. But then we have to check or see if our solutions are right, which is where Marissa comes on. Do you want to kind of walk us through this one?
So I started by rewriting my equation, and then I plugged in 2 first and got the square root of 2 minus 2 equals 2 minus 2. And the square root of 0 is 0, so it's going to equal to 0, so that works. And then I plugged in 1, and I just realized I did that backwards.
Oh, oh yeah, you're
No, I
good.
didn't.
I think it is 2 minus 1 here. That's okay.
Which would be 1. Yeah, it's 2. Okay, so that would be 1, and then 1 minus 2 is negative 1.
Yes.
So 1
All right, that works with me. Oh wait, that doesn't work. Sorry, you're right. That does not work. Yes. So what you said doesn't work with me, but it doesn't work. There we go. Okay, so looks like we only have one answer here because one of our answers didn't work out. Any questions on example 7? All right, I think we're feeling pretty good on doing examples with square roots. Just remember to check your answer and remember to FOIL. A lot of people forget to FOIL on tests and quizzes, so make sure you're doing that step. Okay, we're actually going to move on to a new section, which is still in our set of guided notes here. Still talking about funky equations, and sometimes our equations might not even have an equal sign because they're not equations, they're inequalities, okay? So I know these types of things kind of scare people. We will go through it. I promise it's not that bad because there's always something you can fall back on. Okay, so inequalities, well, things that aren't equal, okay? Inequalities involve things that either have a not equal to sign, a less than, a greater, or a less than equal to or greater than equal to sign. So all these types of symbols are involved in the inequality kind of realm. Okay. Now there are ways to graph the solutions to inequalities, and we'll talk about how to do that now. And I think the best way to go over this is to go through a couple examples. So let's take a look at our first example. We have x is less than or equal to 2, okay? Now, I think we've seen some of this in high school before. When we draw a picture of our solution, we either use an open circle or a closed circle, and we draw arrows to figure out where our answer is going, okay? So, well, we have 2. Let's draw a circle of 2. And since we're less than or equal to, should I close the circle or open the circle? Close the circle, right? So I'm going to fill in the circle. And what the filled in circle means is or equal to, okay? Okay, so when we have less than or equal to, greater than or equal to, we're filling in the circle, okay? Now I want to see if some of you can do this in your head. Do you think my arrow is going to point to the left or to the right? To the left, I think I heard it. Okay, it's left because we're less than or equal to 2. But I'm going to show you something that you can fall back on because I'm actually not very good at reading these symbols and figuring out which way the arrow goes, which is kind of embarrassing. That's okay. If you're ever confused where the arrow should go in your graph, you can always check to see if something on the number line works. And the way I like to go about this is, since we have kind of a division at this 2, our arrow is either going to go to the left or it's going to go to the right, right? It's going to go either way, okay? And what the left arrow means is that any number from the left is going to fit the inequality. The inequality is going to work out. And everything from the right, since there's no arrow, is not going to fit the inequality, okay? So to check to see if our answer is right, we can literally pick any number less than 2, plug it into an inequality and see if it works out, okay? So pick any number less than 2. Give me a number less than 2. 1? Yeah, 1's less. Okay, sorry. I don't know why that took a while. Okay, let me let x equals 1. Okay, plugging it into my inequality. Is 1 less than or equal to 2? Good. Okay, now since I picked 1 and 1 is on the left of 2, and that worked out, everything on the left of 2 is going to work out, okay? And let me just pick another one. Let's pick x equals, give me a number greater than 2. 3? I heard 3, I heard 5. Let's do 3. Okay, is 3 less than or equal to 2? No, right? So because the inequality doesn't work out, there shouldn't be an arrow on that side of the graph. I think I got a chat. Okay, Amar, you can leave early. That's okay. I'll post the video. Okay. Okay, so when we draw a graph, we can always fall back on checking. If you're good at reading less than or equal to signs, you don't have to, but there's always something you could fall back on. Okay, I'm going to give you an alternate notation. This is going to be notation that we use on WebAssign, which kind of freaks some people out, okay? Okay, so the alternate notation I'm going to talk about is called set builder notation. And I think this is some things that you've talked about before as well, okay? Looking at my arrow, looks like my arrow goes from negative infinity. It goes all the way to the left, and it kind of stops at 2. Okay, so let's just write where our arrow goes. We know that it goes all the way to the left, which is where negative infinity sits, and it goes up to 2. Once I write these two numbers, I have 2 options. I can write a parentheses or a bracket. Okay, we'll talk about what to use for each of these. Let's focus on the 2 for now, okay? Should I put a parentheses or a bracket next to this 2? I don't remember. A bracket, good. A bracket means that we're including 2, okay? So a bracket means includes. Okay, parentheses means we don't include it. We'll talk about that in the next example here. Okay. Anyone know what to use for infinity signs?
Parentheses.
Parentheses, good. Infinity isn't actually a number, so we never actually reach infinity. Okay, so for infinity, we're always going to use a parentheses. Okay, so always parentheses for infinity. Okay, so this is an alternate notation. It just tells us where the arrow is, and it's easier than kind of drawing it if we wanted to like type it out or something. Okay, let's do our second example. We have x is greater than 3, but we're not equal to. When we draw our picture, I'm going to draw a circle at 3. Am I leaving it open or filling it in? Leaving it open, right? Because we're not equal to. Okay, so just leaving that one open, okay, because we're not including it. Should my arrow go from the left or to the right?
The right.
The right, good, because we're greater than. Now, if you're ever confused, we can always plug in some numbers, okay? So I'm just going to do that real quick because I like to do things to the extreme. If we wanted to check, I could pick a number less than 3. I'm going to choose 0. Okay. Is 0 greater than 3? No, good. So that's why there's no arrow anywhere to the left of that circle. Okay. I can also pick x equals 4, which is to the right of my circle. 4 is bigger than 3, so I'm good. That's why the arrow is pointing to the right. Okay. All right. Set builder notation. What 2 numbers are going to be in my set builder notation? Good, good. 3 and positive infinity. Since my arrow is going to the right, I'm hitting a positive infinity. I'm getting really big numbers here. Okay. All right, parentheses or bracket on the 3? Oh, I hear a bracket, I hear a parentheses. Which one is it? It's a parentheses because we're not including 3. It's not a less than or equal to sign. It's not, yeah. So it's a parentheses because we aren't, yeah. Okay, we aren't including 3. There's an open circle at 3. We have a parentheses, no bracket. Okay. Parentheses or bracket on the infinity? Parentheses. We always have it parentheses when we're dealing with infinities because we never really touch it. Okay. Let's do one more. We have -2 is less than or equal to x, which is less than 1. Okay. We have 2 numbers here. It looks like x is kind of sandwiched between them. Let me just draw my 2 circles here. We got -2 and 1. Which one am I filling in? -2, good. Okay, and where's my line gonna go? Good, I think I heard between the 2, okay? Because x is kind of sandwiched between them, okay? Now, if I ever was unsure, we can still check to see if our answers are right. And I know this is overkill, but that's okay. We'll talk about this later. We can always check a number in each of the three areas and see if there should be an arrow, okay? Pick a number less than -2. -3, good. And then we can kind of check, okay, is -2 less than or equal to -3, which is less than or equal to 1? Because that doesn't work out, right? Because the -2 and -3 should not have those signs between them, right? So there shouldn't be any arrow to the left, and that's good because we didn't draw it. A number between -2 and 1. 0, good. Okay, is -2 less than or equal to 0, which is less than or equal to 1?
Yes.
That works, good. So that's why there's an arrow between those two, okay? And I know this is overkill, but let's just choose x equals 3, okay? Is -2 less than or equal to 3, which is less than 1? No, good. So, yeah, I don't know. I feel like I'm doing overkill, but I promise you this will come up again and it will become a little bit more useful than what we have here. Okay. So because the 2 on the outside didn't work and the 1 on the inside worked, that's why we have the arrow between. Okay. Let's talk about set builder notation. We've got a -2 and a 1. I think we're pretty good at that. Should -2 have a bracket or parentheses? Bracket, good, because we're including -2. 1 bracket or parentheses?
Parentheses.
Parentheses, good. Okay. So the set builder notation is just saying where is the arrow or the line or whatever. Are we all good on using our notation here? Okay. Let me do a little check on time here. I think we have enough time to do one example here. Okay, so let's take a look at example number 8. Okay, now we don't have like a simple inequality, we have an equation looking type of thing. Okay, inequalities work very similar to equations, but we'll see something that kind of makes it a little bit harder. Okay, we can solve this just like a normal equation. We can subtract, add, whatever we want. Okay, we have -3x is less than 7. Okay. Now I want you to pay attention to this step here. Okay. Yeah, right. So I have a -3 times an x. Okay. We would divide by -3 on both sides. Okay. And we're left with x and a -7/3. The only difference between inequalities and equations is whenever we multiply or divide by a negative number, we flip the sign. Good. We flip the sign. So this sign just goes to the other side. Okay. I have this little highlighted box here. It says that when we divide both sides by an inequality by a negative number, we have to flip the sign. This also goes with multiplication. I forgot to put that in there. Okay, so when we either divide or multiply both sides of an inequality by some sort of negative number, we have to flip the sign. Okay. All right, so we have x is greater than or equal to, or gosh, x is greater than -7/3. Okay, why don't we graph our answer and see how we write our answer in set builder notation. Okay, let me just draw a graph. Maybe we have 0, 1, 2, -1, -2, -3. I think -7/3 is around here. Okay. Yeah. Do I fill in or not fill in my circle?
Not.
Good. Don't fill it in. And should my arrow go from the right to the right or to the left? To the right. Good. If you were ever unsure where this arrow goes, you can always plug in an x value. Why don't we just do that? Okay. So let's just plug in some answers. Okay. Let's try. Can someone give me an x value to the right of my point? 1 is good. Let's do that. Okay. Well, let's plug in 1. -3 times 1 plus 4 is less than 11. Okay. That gives me -3 plus 4 is less than 11. Is 1 less than 11?
Yeah.
We're good. Okay. Now on the other side, if you wanted to try something, you can also plug it in. You'd find that it wouldn't work, which is why there's no arrow to the left. Okay. So we have our graph. What two numbers am I writing down for set builder notation? Good. -7/3 and positive infinity. Is -7/3 going to have a parentheses or bracket?
Parentheses.
Parentheses, good, because we're not including it. Is infinity going to have a parentheses or bracket? Parentheses, good. This is what you would type in for WebAssign, by the way, is the set builder notation. Okay. Any questions on example 8? Okay, I don't think we have enough time for example 9, so I'm going to let you out like 3 minutes early.